Hey, how are we all doing? I'm going to start with a question. Who was here at 4:45 yesterday? Maybe a show of hands. Yeah, not sure what happened there. This is the Connexin keynote now. We had some sort of schedule, I guess, issue. So you're in the right place right now if you've come to see Connexin talk about dense network deployments. That's what we're here for today. So before I jump into things, I've got quite a bit to say. There's possibly going to be some questions that come out of it, so I'll ask if you don't mind just saving it for the floor afterwards. That'd be really good. And that means I can just rattle through and make sure we get the content done. It's also worth just noting, I will also be doing a piece with Multitech later on the theatre stage. I think it's just after 12, so you're going to find out a bit more about the stuff that I'm talking about in that as well. So, as I say, I'm from Connexin. We're here talking about dense network deployments, and we're going to quickly dive into the whys, the hows, and the lessons learned as a result of us doing dense network deployments. But let's start with a big question. Who's this guy? I'm new here. I've not been in the IoT industry particularly long. In fact, I only joined Connexin's IoT team just after TTC last year. So as soon as Dan Priest got back from his keynote last year, basically the next business day is when I started. So I'm responsible for the IoT network within Connexin. I work with a great team of different technologists, and I'll be referencing some of those guys today. My history is probably similar to quite a few of you guys. I've come from a traditional IT networking background. I used to work for some of the big companies in that space, working for other big companies. They were my customers. And I found myself getting really frustrated because IT is great, but the OT, where the production side of things, that's really interesting, that operational technology. And the tool set that I had in an IT space just wasn't equipped for some of these interesting additional challenges. And I kind of got fixated on IoT. Of course, as a technologist, I was aware of it in the industry. But then to actually move into that space took a little bit of time. And I was really fortunate to find a role with Connexin, where I'm very happy to be today, with somewhere, an organization which has the same kind of growth aspirations and visions. So that's where I took myself across to there. So with that, as I say, I'm not the everything of IoT. In fact, I'm supported by some really good guys, and a quick shout out to them because they've helped me build some of the content and fundamentally do a lot of the operations within our teams. Dr. Oktay Chetinkaya and Omar Ari, they're two of our lead RF planners in the team. These are the guys that are doing a lot of the dense network planning. They're really important to me, and they're really important to everything that we actually offer in Connexin. And a big shout out to Dean as well. Dean possibly doesn't need an intro to some of you, but to us, at least in Connexin in the UK, he's Mr. LoRaWAN. He's taught me an awful lot about the technologies that we're here about. But it extends out. It's not just these guys, the rest of the company and the industry at large. It's really nice to be here because the environment, it's that education, that inspiration, that learning that's sort of possible. So the theme throughout this is we're going to share a bit with you. If you want to come and find us afterwards and share a bit back with us, that would be really appreciated. We'd love to hear from you guys. So let's start. Why? Why are we doing dense networks? Why is Connexin doing dense networks? We start with the aspiration that Connexin IoT has. We want to be the #1 UK IoT network provider. That's what we want to do. You're not going to go out there, though, and just deploy a network. It costs a lot of money to do that, so you need to have a customer that wants to have network deployed in an area so you don't just put yourself straight out of business. So in order to do that, we've been looking at the industry, looking at the market, and see who needs these kind of services. And we have found that in water companies. So we, at the moment, typically are building networks for water companies in the UK. And why water companies? Well, they're large private organizations. They're regulated, though. They cover these big geographic areas. They are ready for digitization. In fact, in their terminology, the type of stuff that we do, advanced metering infrastructure, they call it AMI, so smart water metering using LoRaWAN, basically. So they're ready for it, but also their use case is really nicely distributed because they have a water meter where there's a property. And where there's a property, we can provide coverage, and that's generally covers these large areas. So if we're building a network which we want to reuse for other use cases, if we have population count and we really have property count in our network coverage area, then we're in the right place. We're delivering for the right thing for our future plans. Of these guys today, you'll know through previous stuff that we've done at TTC and also press releases that Connexin are already working with the likes of Yorkshire Water and Severn Trent Water. In fact, the presentation last year was about the work with Severn Trent Water. These guys, we're not doing everything in those areas just yet, but they're starting to grow. They're not in a position to just go, here's a big wad of cash, go and install network everywhere. So we're incrementally deploying networks in their areas based on where they are ready to deploy. But we're also working with a few other unnamed water companies, either in trial phases or in bid processes with those, with varying levels of success. But we're moving in this space to effectively, as you can see, try and get our network covering coast to coast in the UK. Here's the rub though. AMI, Advanced Metering Infrastructure, delivering a network for subterranean water meter sensors, that's really hard. If you think about connecting your ideal sensor, it's going to be something that's elevated, it's off the ground, it's in clean air. No. Your typical AMI sensor looks like this. So a sensor needs to be attached to a water meter. A water meter is in line with the water meter infrastructure, the pipe that's underground. So the sensor is being clipped on top of that water meter sensor, and it's subterranean. So straight off the bat, we're trying to get a signal out of a pit that's buried. That signal is propagating from a sensor which is at least half a meter underground. And then these pit structures, they look like plastic, but quite often that lid at the top is reinforced by metal as well, because these are boundary boxes. They're designed to be on property boundaries where cars and stuff like that will drive over them. So the level of attenuation, just getting the signal out of that pit is huge. We model in our research and sort of some tests, we're looking at 26 to 28 dB loss just to get to the clean air. That first half meter alone is the most difficult bit, and it strips out all of the energy from the signal. So that 26 to 28 dB, that's like 99% energy loss from the original transmission, right? It's huge. So all we've got left to play with is that final 1%. So we have these constraints, these suboptimal locations of sensors, huge losses, and these variable environments, because properties are everywhere. They're in urban environments, they're in rural environments, they have varying construction around them. But our customers also have these requirements. They want attach rate. Right? They want to know that if they're putting a sensor in the ground, it is going to connect. And they need an assurance around that, because if they put 1,000 sensors in the ground and only half of them connect, that's a huge wasted amount of money. So we need to build a network which is facilitating a good attach rate. We also need a good packet success rate. They're deploying tens or hundreds of thousands of sensors. The difference in the activity of having to replace them after 10 years versus 15 years, that's really big. That's a huge operational cost that they want to try and push out as much as possible. But we know those sensors, one of the most, or the biggest draw on the power consumption is, of course, the time on air. So we're trying to design the network to accommodate for optimum data transmission, which means we're pushing towards higher data rates, lower spreading factors, to reduce the time on air, to increase the battery life of those sensors. So we're taking these constraints, taking these requirements, and we're wrapping it all in a service. Easy, right? So the way that we're actually building for that service is this dense network. We fundamentally can't get around the laws of physics, and we just need to get our gateways as close as possible to those sensors in order for this to work. That dense network, it does offer us some other benefits. It offers us things like resilience, because we have received diversity. A singular sensor might actually be picked up by multiple different gateways, which is great when you're deploying a network everywhere. Because if a singular gateway has a challenge, at least there's another one's picking up that signal. It also gives us a huge amount of data, which I'll talk about in a sec. That dense network, doing that is really tricky, because you're balancing that fine line between putting enough gateways in there that you're actually facilitating the use case, but putting too many that it's just unviable as a business, or it drives the price point up. So it's a real challenging balancing act. To give you an idea when we're talking about dense network, what that really means, the typical tenders that we're seeing at the moment, we're talking about 1 million sensors that they want to connect. And for us to do that, we're talking about thousands, several thousand gateways deployed in dense configuration. And when you think about that million, I mean, population of the UK is something, I don't know, 70 million or something like that. This is a really small part. Thousands of gateways for a very small part of the landmass. If things go well, if Connexin continues on the trajectory that it thinks it's on, doing what we're doing and being successful with water companies, the numbers that we're anticipating here by 2030 is there'll be between 11 and 15 million sensors on our network. It's huge. It's massive. And of course, thousands and thousands more gateways. But let's go back to the top. Why are we doing this? Let's quickly summarize on that point. We want to be the IoT network provider in the UK that's #1, but AMI is really hard. So when I'm designing for this use case, for subterranean, these RF blooms don't look that impressive, but I'm already modeling for a 28 dB loss here. When I then start facilitating other use cases, because quite frankly, if there is a use case that involves a more subterranean asset, we probably wouldn't pursue it. It's just going to be a little bit too difficult. But all of those indoor use cases and exterior use cases, the network that we're building for a subterranean environment, we can easily facilitate all the rest. So this is how it maps to our ambitions and our strategy and what we're doing. Now, I said, I think, at the start, I'd share some lessons. So I have 3 lessons here today, short, punchy lessons, things that we've learned to do as part of deploying a dense network. So lesson number 1, auto onboarding. If you're deploying thousands upon thousands of gateways, you need to get good at getting them out in the field. So we've worked very closely with our partners at Multitech to build an onboarding process in factory where effectively we have our own SKU with those guys, which has all of the APN details on there, for example, so that the backhaul is ready to go as soon as it's needed. It's auto onboarding to the LNS, the right certificates are in the right places, they're exchanged with TTI. We literally are getting a box from Multitech and giving it to our installers, and then installers with no IT capability can go and fit that thing, and the first time it's powered up, it's connecting onto the network. It's registering itself on the LNS, we can go. Singular gangs of guys are basically installing upwards of 10 gateways a day for us, which is the run rate that we need to keep up with, and we're deploying multiple gangs when we need to. So lesson 1, look at auto onboarding. Lesson 2, optimizing your planning. If you're going to have customers of a network and you're designing for them, then you need to have the planning done properly. Oh, we're back. We need to have the planning done properly. I'll keep rolling. So what we've done is, in order to optimize this, if you're modeling for thousands and thousands of endpoints, the compute time is through the roof. Even if you're using the best tooling on the planet, you're just going to take hours and hours of compute cycle. So when we're looking at the numbers, what we do is we aggregate using models like k-means clustering, so that we can produce a singular weighted point for a number of sensors and actually model on that instead. Then if we need to do some finer refinements, we can do that. But what that means is, for the graphics I showed you before, that was for modeling somewhere in the region of, and keep me right here, it's in the hundreds of thousands of sensors. If we did that in a traditional way with every single one modeled in the RF planning, it would take an awful long time. But in this environment, the way that we're doing it, we're reducing it to days instead of basically months of compute time. And lesson number 3, eat your data. So wireless networking is variable in performance. There's people out there that wouldn't even put SLAs around Wi-Fi networks, and we're trying to do it in this hugely variable environment. And so maintaining those SLAs are difficult. The only way that we're going to get good at this game is if we ingest all of that metadata, so literally everything, every single packet received and all of the metadata around it is going into a data lake, and we are analyzing. We are looking at ways to optimize this. It improves our planning, and it makes a more efficient network. I'm just going to finish on this. Does anyone know who this guy is? Silence. I like throwing in a weird slide or two. This is Abraham Maslow. He's a 20th century American psychologist. He's famous for his hammer. Anyone know? Maslow's hammer. If all you have is a hammer, everything looks like a nail. We are a network provider with LoRaWAN. If I treat every problem that comes across my way as something I can fix just by throwing more network at it, that's not the right way of doing things. I'm going to be blind to all the potential. The lessons that I've shared are the things that we're doing on the periphery with our partners and others to improve the actual network itself, not by throwing more network, but by doing more on the outside. So my call to you as I finish today is, if you have ideas or you want to discuss the things that we're doing, you think you can help, you want to challenge us, please come find us on the floor.